Across the globe, civilizations have long held a reverence for rain. From ancient rituals to modern-day prayers, rain has always been a symbol of life and renewal. It is a force of nature that has shaped cultures, inspired myths, and driven human innovation. It sustains life, nourishes crops, and replenishes rivers. The gentle patter of raindrops on leaves, the rush of water filling streams, and the sight of fields turning green are all testaments to rain's vital role in our ecosystem. Yet the distribution of rainfall is a fickle dance of nature, often leaving some regions parched while others are deluged. This uneven distribution can lead to devastating droughts or catastrophic floods, affecting millions of lives and livelihoods. In an era of growing water scarcity, could humans hold the key to unlocking the heavens and summoning rain at will? As climate change exacerbates weather extremes, the quest for reliable water sources becomes ever more urgent. The concept of artificial rain, also known as cloud seeding, offers a tantalizing glimpse into a future where water scarcity might become a relic of the past. By dispersing substances into the atmosphere, we can encourage cloud formation and precipitation. Imagine a world where arid landscapes could be transformed into fertile fields with the help of science. This technology holds the promise of turning deserts into oases, providing food and water security for millions. Picture drought-stricken communities finding relief as rain clouds gather overhead, seeded by human ingenuity. The joy and hope that rain brings to these areas cannot be overstated. This is the promise of artificial rain, a potential game changer in our quest to secure water for a thirsty planet. It represents a beacon of hope for regions suffering from chronic water shortages. But as with any powerful tool, it comes with its own set of challenges and considerations. Ethical, environmental, and legal issues must be carefully weighed. The allure of artificial rain lies in its simplicity. The idea that we can influence weather patterns with relatively straightforward techniques is both fascinating and promising. By mimicking nature's own processes, we can potentially influence the weather patterns that govern our planet's water cycle. This could lead to more predictable and controlled rainfall, benefiting agriculture and water management. But the question remains, can we harness this power responsibly and effectively? The debate continues as scientists, policymakers, and communities grapple with the potential and pitfalls of playing rainmaker.
Cloud seeding might sound like something out of a science fiction novel, but the science behind it is firmly grounded in reality. This innovative technique has been developed and refined over the years to help manage water resources and mitigate drought conditions. It's a fascinating intersection of meteorology and technology, where human ingenuity meets the natural world. It all begins with clouds, those fluffy white masses that drift across our skies. These clouds are not just beautiful to look at, they play a crucial role in the Earth's water cycle, acting as reservoirs of moisture that can be tapped into. Clouds are formed when water vapor in the air condenses around tiny particles called condensation nuclei. This process is essential for the formation of raindrops, which eventually fall to the ground as precipitation, replenishing our water sources. These nuclei can be anything from dust and pollen to sea salt and even pollution. Each of these particles provides a surface for water vapor to cling to, initiating the condensation process that leads to cloud formation. This is where cloud seeding comes in. By artificially introducing additional condensation nuclei into clouds, we can enhance the natural process of raindrop formation, potentially increasing the amount of precipitation that falls. By introducing additional condensation nuclei into clouds, we can encourage the formation of raindrops. This is typically done by dispersing substances that act as nuclei, such as silver iodide or dry ice, into the clouds. The most common method involves dispersing silver iodide or dry ice into clouds, either from aircraft or ground-based generators. These substances serve as artificial ice nuclei, which are crucial for the cloud seeding process. These substances act as artificial ice nuclei, prompting supercooled water droplets in the cloud to freeze and grow. This freezing process is essential because it leads to the formation of ice crystals, which can eventually become heavy enough to fall as precipitation. As these ice crystals become heavy enough, they fall from the sky as precipitation. This can take the form of rain, snow, or other types of precipitation, depending on the temperature and atmospheric conditions. The process is a delicate dance with nature, requiring careful monitoring of weather conditions and cloud formations. Meteorologists and scientists work together to determine the best times and locations for cloud seeding to maximize its effectiveness. The success of cloud seeding depends on a variety of factors, including the type of clouds present, temperature, and wind patterns. Each of these elements must be carefully considered to ensure that the seeding process is as effective as possible. While it's not a foolproof solution, cloud seeding has shown promising results in enhancing rainfall in certain regions. This technique has been particularly useful in areas that suffer from chronic water shortages, helping to alleviate drought conditions and support agriculture. The benefits of successful cloud seeding extend beyond just increased rainfall. It can lead to more robust agricultural yields, replenished water reservoirs, and overall improved water availability for communities. This makes cloud seeding a valuable tool in the ongoing effort to manage our planet's precious water resources. As technology continues to advance, so too does our ability to refine and improve cloud seeding techniques. Ongoing research and development are crucial to making this process more efficient and effective, ensuring that we can continue to harness the power of nature to meet our water needs. In the end, cloud seeding represents a remarkable blend of human innovation and natural processes. It's a testament to our ability to work with nature, rather than against it, to create a more sustainable and resilient future for all.
Water, the elixir of life, is facing an unprecedented crisis. This essential resource, which sustains all forms of life on Earth, is becoming increasingly scarce. As populations swell and the planet warms, the demand for water is skyrocketing. Urbanization and industrialization are putting immense pressure on our water resources, while our supplies dwindle at an alarming rate. Climate change exacerbates the situation, leading to prolonged droughts and unpredictable weather patterns. From the parched farmlands of California to the arid plains of Africa, water scarcity is no longer a distant threat, but a stark reality for billions around the globe. Farmers struggle to irrigate their crops, and entire ecosystems are at risk of collapse. The consequences of water scarcity are far-reaching and devastating. Livestock perish, and communities are forced to travel long distances to find even the smallest amounts of water. Dwindling water resources threaten food security, fuel conflicts, and displace communities. In many regions, the lack of water has led to social unrest and migration, as people leave their homes in search of more hospitable environments. Rivers are running dry, lakes are shrinking, and groundwater aquifers are being depleted faster than they can recharge. This depletion not only affects human populations, but also wildlife that depends on these water sources. The situation is particularly dire in arid and semi-arid regions where communities are already grappling with the harsh realities of limited water access. Women and children often bear the brunt of this burden, spending hours each day fetching water. The urgency of the water crisis demands innovative solutions. Scientists and engineers are working tirelessly to develop new technologies and strategies to manage and conserve water more effectively. As traditional water sources become increasingly strained, the need to explore alternative approaches, such as artificial rain, becomes all the more critical. Techniques like cloud seeding and desalination are being explored to supplement our water supply. Community efforts in water conservation and rainwater harvesting are also playing a crucial role. By adopting sustainable practices, we can collectively make a significant impact in mitigating the water crisis. Education and awareness are key. Teaching the next generation about the importance of water conservation and sustainable practices ensures that we are better prepared to face future challenges. Global cooperation and policy-making are essential. Governments and organizations around the world must work together to create and implement effective water management policies. Innovative solutions, such as advanced water purification systems and solar-powered water pumps, offer hope. These technologies can provide clean water to remote and underserved areas. By addressing the water crisis with urgency and innovation, we can ensure a future where water is abundant and accessible for all. Together, we can turn the tide and secure this precious resource for generations to come.
In the face of mounting water challenges, governments and organizations worldwide are scrambling to develop effective water access policies. These policies serve as blueprints for managing and allocating precious water resources, ensuring equitable access for all. WAPs encompass a wide range of strategies, from promoting water conservation and efficiency measures to investing in infrastructure projects like dams and reservoirs. Central to any successful WAP is the need for a holistic and integrated approach. This means moving beyond simply increasing water supply and focusing on demand management, pollution control, and ecosystem protection. Effective WAPs recognize that water is not just a commodity, but a vital resource that underpins every aspect of human and environmental well-being. As we navigate the complexities of water scarcity, it's essential to consider the role of emerging technologies like artificial rain within the framework of comprehensive WAPs.